Hi friends, it's Amy here. Now in this activity, this lesson, your students, your children are going to be working on determining even and odd numbers. Okay, so the standard now that we are working on, we're switching gears a little bit in the standard. We'll talk about why. MA for math, 3 for the grade level. AR is algebraic reasoning. The standard is 3. Identify numerical patterns, including multiplicative patterns. We're not going to be working on the multiplicative patterns, just on numerical patterns. And then the benchmark is 3.1. Determine and explain whether a whole number from 1 to 1,000 is even or odd. You may say, well, wait, this whole unit, we've been focusing on a standard that was about place value. Well, there's a clarification that the instruction includes determining and explaining using place value and recognizing patterns. So there is some focus on place value, so that's why it's placed here at the end of this unit. All right, so you likely learned that we know a number is even by just looking at the last number. If it's 0, 2, 4, 6, or 8, it's even. If it's 1, 3, 5, 7, or 9, it's odd. Okay, well, again, as with all of the other lessons, wanting students to have to really understand, not just memorize a rule, but to understand what it means for a number to be even. So an even number, the actual definition is it's a number that can be decomposed into two equal whole numbers. So if you've got those base 10 blocks, I really encourage you to work with them. Okay, so we could take the 124 and show that with base 10 blocks. Okay, so here's 100 and there's 20 and then there's 1, 2, 3, 4. Now, can we split this into two equal parts? Well, we can't break 100 apart, but you can work with your students about replacing 100 with 10 tens. If your children still are struggling with understanding that 10 tens make 100, then you can always, if you'll look at this, let me get my 10 tens here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, all of these are great opportunities to go back and reinforce some prior learning because we can show them how, look, 10 tens is the same size as 100. Now I can split those apart. Okay, so we still got our 24 into 5 tens and 5 tens. Okay, and then we can put one of the tens here, one of the tens here, two of the ones here, and two of the ones here. All right, so we can split this number apart into two equal parts, 62, 10, 20, 30, 40, 50, 62, and 62. So we can write that as, yikes, that was loud. So we can write that as 124 as 62 plus 62. So we can write it as two equal numbers. 128 we can write as 64 plus 64. Now when we're looking at 115, and again, I would practice with the base 10 blocks. We got 100, 110, and then dropping my base 10 blocks here, and then there's 115. All right, well again, we can't break apart the 100, so I'm going to replace that with 10 tens. Really great to help students continue to make the connections with the base 10 blocks and the numbers as we're working on decomposing here. Okay, because see, if I've got a student that is continuing to struggle, let them practice with this, with showing how, okay, that's the same thing. All right, so now I can split my 10 tens apart, but now I've got a 10. I can't break it apart, can I? So I can take this 110 here and I can change it out for 10 ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, we can see, look, it's the same size, okay? So we can switch that out. Now we can split that into 5 ones here, 5 ones here. Now we can split these 5 ones that we have. Well, I can put 3 here and 2 here. So what we're wanting students to see is that we can get them super, super close. We can get it to, this one is 58, this one is 57. So we can get it really close. But what's that old saying? Close but no cigar. I don't know what that means, but I have to look up what it means. But we can get it super close, but it's still 58 plus 57. All right, I want to pause right there because I know what some of you are probably thinking. It's just so easy. Why are we doing, why, Amy, why on earth are we doing this? Why are we taking these? That was a lot of work when all I need to do is look at the last digit. Okay. Okay, two things. First of all, for you, it's easy to look at the last digit because you're far enough along now that that's just rote memory. 1, 3, 5, 7, 9 in the ones place it's odd. 2, 4, 6, 8, 0 in the ones place it's even. That's just rote memory. It's easy. This is the first time though that your children are hearing this. So now they're having to memorize a fact. They're having to memorize something. So imagine when they're on taking a test down the road and they're going, wait, is it 0, 2, 4, 6, 8 that's even or odd? So we're building in this number sense, this conceptual understanding. Number one, that's the reason that working with these base 10 blocks is important. Number two, the beauty of math is that you have opportunity to practice other skills sometimes while we're working on a current skill. When we try to split these into 2 equal parts, we're decomposing numbers. That's something they did in an earlier lesson. That's something they're going to need to do with addition and subtraction. They're going to need to decompose numbers. So this gives you a perfect opportunity to practice with your children on decomposing numbers, in addition to just looking at are they even or odd. Okay, well, 107, if you worked with that one, we could write it as 54 plus 53. So we want to introduce it to them before jumping into the pattern about the ones place. We want to introduce and get them to understand that definition. An even number, it can be decomposed into 2 equal parts. An odd number cannot. Okay, so what are the patterns with even and odd numbers? Well, now we come to the part where we learned it. The part that we're probably using is that even numbers have 0, 2, 4, 6, and 8 in the ones place. Odd numbers have 1, 3, 5, 7, and 9 in the ones place. So again, definitely they can use the pattern, but we want them to make the connection also to what an even number actually is. If I'm defining an even number, that's not my go-to definition. It's true that it has one of these numbers in the ones place, but the true mathematical definition is that an even number can be split into 2 equal parts. Okay, so when they'll have homework, they'll have numbers like these. So what I would encourage you to practice both methods with your children for determining if numbers are even and odd. Oh, and I just had a thought I want to throw in. When you talk with them about the patterns in the ones place, maybe write a bunch of even numbers down, write a bunch of odd numbers down, see if they notice the pattern. If they can notice it, they're going to own it. Okay, so now when you practice with them with some problems like these, please work on both methods. Again, it's great practice for decomposing numbers. Now, you do not have to use the base 10 blocks like I did. Your students may be able to look at this and go, all right, well, I can, if I try to divide 15 to split it, we're not dividing yet. If I try to split it into 2 equal parts, I can have 8 and 7. Your students may know that, your children may know that. That is perfectly fine. If they don't, though, that's where the base 10 blocks help them with making the connection. So have them practice both methods, looking at, especially like a number, try some numbers like 515. Okay, we know we could put 200s if we have, because we've got 500s. And you can also practice with just drawing. I know if you look at the student video, we do that with some of them. So like, for example, let's look at 312 since that one is even. We could draw 300 flats, 110, and then 2 ones. Okay, now if they practice with drawing, then we go, okay, well, we can put 100 in a group and 100 in a group. Oh, I can't split 100, but if they're visualizing that hundreds flat, they know it splits into 10 tens. So they're like, okay, we could put 5 tens over here and 5 tens. Mine is very messy over here. So now I've split the 100. Then we get to the 10. All right. I can't break a 10 in half, but I can put 5 ones here and 5 ones here. And then finally, I've got the 2 ones. I can put 1 here and 1 here. Again, it's not taking something and trying to make it complicated. It is building number sense. The idea is not that your student will always do this. The idea is that they will begin over the practice with these base 10 blocks. They'll begin to be able to visualize this and go, all right, well, I know 164, and they can think about how they would break it apart. And guess what? This is going to be so helpful for when they get into division. It's going to really, really help them when they get into division. I promise you, there is a great reasons that we're doing this. It is not to just give you angst and anxiety with homework. It is really to help build that number sense. Okay, so I think we did this one. So we know 312 can be split into 100, 10, 20, 30, 40, 50. And 51, 52, 53, 54, 55, 56. So 156. And over here, we also have 156. So please practice with them with both methods. If they're able to just mentally break them into 2 groups, then, base 10 blocks is not something you have to have. What are base 10 blocks? They are a phenomenal tool if your student is struggling with decomposing numbers. All right, in their homework, they'll also have some true-false statements. These are great to really help the students with building and ensuring that they've got the conceptual understandings. Things like all digits in an even number must be even. That's not true, right? It's just the one in the ones place, like 312. It's an even number, but 3 and 1 are both odd. So, and those true false questions, talk with your students. Well, how could we rewrite this so that it was true? Well, we could say something like the ones place in an even number must be even. Same thing here, 6. Odd numbers must have an odd number in the ones place. That's true. How can we make it false? Have those fun conversations. A number that cannot be decomposed into 2 equal parts is odd. Again, a true statement, but you can have some fun conversations about how could I make that false. All right, now one of the great practices for students is play in math. It is actually a research-based practice that if students are playing while they're learning math, they're going to be more engaged, they're going to have more fun. So if you want to, on a Saturday afternoon, get out and play a game with your students that'll reinforce this, think about doing even and odd hopscotch. Just take your sidewalk chalk or even tape and make a hopscotch grid. You can make it with 20 squares and then put odd numbers in 10 of them, even numbers in 10 of them. Student tosses the beanbag, whatever it lands on. If it lands on an odd number, then they have to jump on all the odd numbers. If it lands on an even number, they jump on all the even numbers. Now, if your student needs extra support with this, with really getting, because there is a time, we do want them to get to the point where they're just know it. So we do want them to get to the point where they just know, all right, 0, 2, 4, 6, 8 in the ones place means even, 1, 3, 5, 7, 9 in the ones place means odd. So if they need extra support, just do 10 grids and just put the numbers 1 to 10 and just let them practice with that if they need some extra support. All right, friends, hope you all enjoyed that lesson. We'll see you in another one.